So our airspeed indicator is at 80 knots, our attitude indicator is at 0 degrees, and our altimeter is at 4,100. And I'm going to dive nose down for 3 seconds and read them again. And now our airspeed indicator is at, let's say, 90. Our attitude indicator is still at 0, and our altimeter is at 3,100 now. And I'm going to go up past our original altimeter height. Okay, so now our airspeed is at 95. Our attitude is still at 0 degrees, and our altimeter is at 5,000. And we're testing the weight of the aircraft in relation to takeoff distance. So first we're going to go into the aircraft weight and put it at 296, which is that. And then we're paused right now, and we're going to unpause and click the top of the screen, and we let the brakes go and make some slight adjustments to keep the aircraft going straight. We are going to gently take off. And then we're going to pause again, and we will check our data, and where all the inputs are at 0, which is here, we take note of the VIND. Oh no, not here, over here. We take note of VIND and the distance in feet. So today we are in a Cessna 172 in Seattle with a payload of 296 pounds. We've turned on the lift vectors, and we're going to be watching the airspeed as we climb for 3 seconds. So I'm going to unpause. 1, 2, 3. And we take note of the airspeed and the lift vectors as well. And now we're going to climb until the lift vectors are almost gone. And as you can see, the lift vectors are almost gone. We pause again, and the plane is stalled. And lastly, to regain speed, we're gonna dive dive nose down with the wings leveled to regain speed. And as you see, we regained our speed because the stall was not too bad. So for part 1 of lesson 4, we're in Seattle flying a King Air C-90B, and we are going to be flying level for 3 seconds with the landing gear retracted. 1, 2, 3, and then we're going to be taking note of the airspeed, and now we are going to be flying level with the landing gear lowered for another 3 seconds, and also taking note of the airspeed. And now the landing is lowered. 1, 2, 3, and we will note the airspeed. And we're going to repeat this process, but for 60 seconds this time. So for part 2 of lesson 4, we will be examining the airspeed with the flaps up and down, and we'll be doing this 3 times each for the flaps up and the flaps down. So we will unpause, and we will fly level, and now we're going to put the flaps down. Now the flaps are down, and we will take note of the airspeed after 3 seconds, and we will do this 3 times, and we'll do the same with the flaps up as well. So today we are in Seattle, and we're going to be trying to land a Cessna 172, and to do this we will head towards the runway, and we will try to reduce the revs to 1,600 RPM and maintain a speed of 85 knots. So to reduce the revs, I will click F1, and we also have to watch the vertical indicator while we do this to make sure the plane doesn't go too low. So our current revs per minute is 2,000. So when we get closer to the runway, I will reduce it to 1,600. And our speed is about 95 knots, and that needs to be at 85. So approaching the runway, there's lights. If they're all red, that means you're too low. If it's half white and half red, that means it's just right. And if it's all white, that means you're too high. So our res is now at 1,600. Our speed is still a bit high. And when we touch the runway, we will deploy the brakes. And we've landed. We'll be covering wing loading. In PlaneMaker, I modified 3 aircrafts with different wing loadings. And in Seattle, we will be collecting data. I have the data turned on in settings. So we will also be changing the weight of the aircraft to 2,500. And we will be taking off and trying to maintain a steady flight. We are going to be doing this 3 times for the 3 different planes, and we're going to be trying to fly as consistent as possible. So now we've taken off. We'll be covering aspect ratio, mathematical modeling, and experimental design. We went to PlaneMaker and we have made 5 different planes with different aspect ratios. After that, we're going to go into X-Plane, go into Seattle, and we will be turning on our data so we can collect data for takeoff distance. We will turn on line 3, line 21, and line 66. We're going to go into our plane and we're going to be taking off so we can record the takeoff distance. And now taking off. So then we're going to go into our data and we're going to look at the graph, and where all the vectors are at 0, we will record the takeoff distance, and we're going to be covering stability and center of gravity. We're going to be turning on the lift vectors and watching them as we climb, descend, and stay level. After watching them, we're going to take note of what they do. So here I will descend, I will climb, I will stay level. And after that, we're going to be collecting data. After that, we are going to change the center of gravity. We will be changing to minus 16.4. And we will also be changing the payload weight to 2,798 pounds. Then after that, we are going to maintain level flight for 3 seconds, and we will go to our data and we will record the elevator deflection. We will repeat this 3 times, and after that we will do this again, but with the center of gravity at 21. So today for lesson 9, we're going to be covering power loading. We went to PlaneMaker and we made 3 different planes with 3 different weight power ratio, and we are going to be flying them in X-Plane. So I will fly the weight power ratio of 600 first. Today we're going to be taking off and we're going to be trying to fly consistently for 3 minutes, and then we're going to be recording our data. And now that I've taken off, I will be flying consistently for 3 minutes. Then I will repeat this with the other 2 aircraft.